Hello students, today we are going to study the effects of refraction in our day-to-day life. Now you might have seen sometimes when a pencil or a stick is kept in a water in the container like this, you can see here. In this container you will find that a pen is kept and you will find that it appears to bend. The image of the pen appears to bend. Actually the pen is not bending, it is a straight pen here. So when we keep it inside, we'll see that it appears to bend. This phenomenon is due to the refraction of light and we'll discuss in detail later on. Now there are certain phenomena in our day-to-day life which is related to refraction of light. We'll discuss one by one. The first phenomenon I have just told you, a stick or pencil held obliquely and partly immersed in water appears to bend. The second, you might have seen that if you place a coin in a bucket which is filled with water, it looks like that the coin appears to be raised. And the third is, a pool of water appears to be less deep than it actually is. Suppose when you have gone for the swimming, you might have seen that the pool appears to be less deep, but when you go inside, then you will find that it is more deeper than you actually thought. This is again due to the refraction. The fourth is when a thick glass slab is placed over printed matter. If you take a glass slab and keep on the letter of your book, then it will appears to be raised. That is also due to the refraction of light. And then a lemon kept in water. You might have noticed that if you take a glass of water and in that you put a lemon, and if you see from the side, you will see that it appears to bigger inside. These are all effects of our refraction in our day-to-day life that we have seen. Now today we are going to discuss this effect and I'll explain how this refraction is causing these all phenomena here. Now let us see how the pencil or the stick, when it is held obliquely and immersed in water, partly immersed in water, appears to bend. This I have shown you earlier also that if we take a glass of water and if we kept a pen or pencil or stick, it appears to bend. Now I am going to explain why this looks like that it appears to bend. It is not actually bending, but it appears to bend due to the process known as refraction. So I will explain how it happens. Now you can see here, this is a water and this is air. This is water. So a stick is kept, or you can say take a pencil. It is a straight pencil here, and this is this part of the pencil, that is O. That ray of light is going from water to air. As you know that the water is a denser medium and air is a rarer medium. So when a ray of light goes from a denser medium to rarer medium, it will bend away from the normal. As you can see, instead of going here, it bends away from the normal. So these two rays, which are, one is OC and the other one is OD, when going from water to air, it bends away from the normal in the direction of CX and DY. These two rays will not meet with each other, but it appears to meet if we produce it backward and it is produced here. So the image of the point O is formed here, which is virtual and erect. So image of this point O is formed here. Likewise the image of this point will be formed here. Likewise the image of this point will be formed here. So the image of this whole stick, which is inside the water, will be like this. So it will appears to bend. So due to the refraction of light, this stick or a pencil which is kept inside the water appears to be bent. Now let us discuss one more effect of refraction of light. This you might have observed many times, that an object, or we can say coin, placed under water appears to be raised due to refraction of light. Now see, this is a container containing water here and this is air. So in the water we have kept a coin here that is marked as O, and the ray of light going from the O that is OA and the OB. When going from denser medium to the rarer medium, as we know the water is denser than air, so it goes from rarer medium, denser medium to rarer medium. It will bend away from the normal. So you can see this light, ray of light OA is bending in the direction of AX, and the ray of light OB is bending in the direction BY, which is going away from the normal. So these two rays will never meet with each other, but if they are produced backward, you can see if they produce backward, these two rays appears to meet at this point, forming a virtual image of the object of the coin, that is denoted as I. So you can see this coin which is actually placed here appears to raise. The image of this coin is formed at this point I, so it appears to raise at this point. So that's why this is due to the refraction of light. An object or a coin placed under water appears to be raised due to refraction of light. Now let us take the third effect of refraction in our day-to-day life. You might have seen when you are started the swimming, then when you are looking from outside, it looks like that the pool is less deeper. But when you go inside, you will find that it is more deeper. Suppose it is, let's say the actual depth of the pool is 4 feet. Then from outside it appears like it is having a depth of only 3 feet. But when you go inside, then the depth is around 4 feet. This is due to the refraction of light. So let me explain this effect. Now this is a pool here. This is containing water. This is having water and this is air. So the bottom of the pool, which I marked O here, the ray of light from the bottom of the pool O is going in this direction OA and OB. So when these ray of light OA moves from water to air, that is from denser medium to rarer medium, it bends away from the normal, and likewise the ray of light OB bends away from the normal in the direction of BY. So these two rays will never meet with each other. So but these two rays, when they are produced backward, they appears to meet at this point, which forms a virtual image. So the image of the point O, that is the bottom of the pool, is formed at this point, that is upper than or raised from the bottom of the pool. So the image of this point is formed here. Likewise, the image of this will be formed here. The image of this point will be formed here. Similarly, the bottom of the pool, the image of the bottom of the pool will be formed at this place. So this is the real depth of the pool, but from outside it will appears the apparent depth will be this much. That means this depth you will see from the outside, but really it is having this much depth. So if it is 4 feet, the real is 4 feet here, 4 feet, then the apparent depth is around 3 feet. So this is how the reflection of light is causing a pool of water appears to be less deep than actually it is, and this is again due to the refraction of light. Now, so there are many phenomena. Likewise, when we take a glass slab and we put on a printed matter, or let's say a letter, then the letters will be raised appears to be raised, and this is again due to the same phenomenon, and then same concept will be there only also, that is due to the reflection of light. The letters which is kept under the glass slab will appears to be raised. Now let us take the refraction through a rectangular glass slab. In the figure you can see this is a glass slab I have made here. It's a rectangular glass slab, and the ray of light which is entering from air to glass slab, as we know that air is a rarer medium and glass is a denser medium. So when a ray of light from air to enters from air to glass, it will bend towards the normal because the light is traveling from rarer to denser medium. This is the incident ray and this is the refracted ray. So when ray of light comes from air to glass, it bends towards the normal. This is the normal here, and this angle is known as angle of incidence, and this angle is known as angle of refraction. The angle between the normal and the incident ray is known as angle of incidence, and the angle between the refracted ray and the normal is known as angle of refraction. and here you can see that the angle of incidence is greater than angle of refraction. Now if the ray of light moves from glass to air, in that case it will again bend, but this time it will bend away from the normal. So this is a normal we have drawn, and this is bent away from the normal. This is known as emergent ray, and the angle between the normal and the emergent ray, denoted by E, is known as angle of emergence. It will be parallel to the ray of light which is entering if there is no deflection here, if there is no glass slab. In that case the incident ray will go straight without any bending, but due to this glass slab the incident ray is this is refracted towards the normal, and when it goes from glass to air it is refracted away from the normal. So this is the ray which is emerging out of the rectangular glass slab, will be parallel to the incident ray which is coming there, and this displacement is known as lateral displacement. And this lateral displacement depends upon three factors. The first is the refractive index of the glass slab. If the refractive index of glass slab is more, the lateral displacement will also be more. Second, the angle of incidence. If the angle of incidence is more, then the lateral displacement will be more. That means greater the angle of incidence, more will be the lateral displacement. And third is thickness of the glass slab. So if the thickness of the glass slab is more, then the lateral displacement will be more. So this is a diagram showing the refraction through a rectangular glass slab. Here the refraction is taking two times, one entering from air to glass slab, bending towards the normal, and second case when light is going from glass to air, it is bending away from the normal. This is angle of incidence, this is angle of refraction, and this is angle of emergence. So this is how the light refracts through a rectangular glass slab.